Can a moon be the twin of the Earth? Throughout the solar system, there is only one celestial body that is eerily similar to Earth: Saturn's moon, Titan. Only on Titan are there landscapes on the surface with rivers, lakes, and seas. What scientists have discovered on Titan has taken their breath away. The evidence of potential life on Titan has been provided, and this life probably looks even stranger than we thought. Come along on this journey to a fascinating world more than 1 billion kilometers away. Titan, a moon resembling our Earth. When the Dutch astronomer Christian Huygens observed a small object near Saturn on March 25, 1655, he had no idea what this discovery would mean for humanity one day. Today, we know that Titan is the second largest moon in the solar system and the only truly Earth-like object. Only on Titan are there flows of liquid substances that form rich landscapes with lakes, seas, and rivers. The rocky moon Titan is about twice the size of Earth's moon and about half the size of Earth. Its composition is somewhat different overall, making Titan much lighter than Earth. Due to its lower mass, Titan also has a significantly weaker surface gravity. The surface gravity on Titan is about 1.35 meters per second squared, while on Earth, it's about 9.81 meters per second squared. That means the gravity on Titan is approximately 7 times weaker than on Earth. Titan is very well explored. Titan has been visited multiple times by spacecraft throughout the history of space exploration. Pioneer 11 made a flyby in 1979 during its journey through the outer regions of the solar system and provided the first image of Titan. The moon appeared as a homogeneous yellow sphere, and at that time, it was impossible to anticipate the mystery that would be revealed here. Voyager 1 followed shortly after, delivering a slightly darker depiction of Titan. Even after this image, no one had the idea of comparing the moon, which appeared like a juicy orange, to Earth. This perception remained unchanged when Voyager 2 captured an image in 1981 that appeared to be a peculiar blend of the two previous photographs. Cassini's image of Titan was quite different. In particular, the spectrometer recordings provided insights into Titan's diverse surface. At this point, scientists already knew from images taken by Hubble several years earlier that the moon was geologically very active and potentially provided conditions for life. Cassini-Huygens was, therefore, on a very different mission compared to its predecessor probes. The Huygens lander was specifically designed to descend onto Titan and send back the first images and data from its surface. On January 14, 2005, after a multi-year journey through the solar system, the dual probe finally reached Saturn's moon, Titan. About 20 days later, on January 25, 2005, when Huygens entered Titan's atmosphere, NASA scientists held their breath. Would humans soon see for the first time a foreign world resembling Earth, with lakes, landscapes, and possibly even trees or living beings? Titan's thick atmosphere. Until this historic moment, it was as if the mysterious Titan was playing hide-and-seek with curious humans. Enveloped in a thick orange-yellow atmosphere, it was impossible for us to look at the moon's surface until the Huygens mission. Hubble's scans and many other observations with the world's best telescopes had already provided many clues, but they could not be compared to real images and measurement data. Although Titan and Earth are similar in many ways, there are also significant differences. Earth's surface is visible from space. Our planet shines brightly, allowing views of continents, oceans, and the poles. This effect depends on the composition of the atmosphere. Nitrogen, oxygen, and carbon dioxide in the layers, as they occur in our atmosphere, allow sunlight to pass through at all times. The Earth's surface reflects it, making our planet glow brightly and the atmosphere appear transparent. Titan's atmosphere is much denser, and less sunlight reaches its surface. Titan reflects very little light, making it impossible to get an external view of the moon's structures and landscapes. Huygens landing. At 11:30 a.m. local time in the NASA Control Center in Houston, Texas, the Huygens probe separated from the mother spacecraft Cassini. 25 minutes later, Huygens reached an altitude of about 160 kilometers above the surface of Titan. At this point, the parachutes were deployed to slow down the probe's speed and enable a gentle landing. During this phase, the probe collected thousands of data points and performed continuous measurements. These measurements included capturing temperature, pressure, density, and electric fields in the structure of the atmosphere. At 12:08 p.m., Huygens was hovering about 40 kilometers above the surface of Titan. At this altitude, the Huygens Doppler wind experiment, attached to a cable, was activated to measure wind speed and direction. Approximately 10 minutes remained, and there were only 20 kilometers between Huygens and the surface of Titan. At this point, the infrared spectrometer and gas chromatograph mass spectrometer were activated to collect even more detailed data about the chemical composition of the atmosphere. At 10 kilometers above the surface, the probe switched to the mode for measuring electricity and started to detect electrical discharges in the atmosphere. At 12:34 p.m., the Huygens probe finally reached Titan. Descending at a speed of about 5 meters per second, the lander successfully touched down on the surface. Jubilation erupted at NASA, but the most exciting part of the mission was yet to begin. After landing, the probe started recording data about the ground composition, temperature, and pressure. Huygens transmitted data and photos from the surface for 90 minutes, then the probe's batteries failed. The mission was designed to be brief from the beginning. The time was sufficient for scientists to gather all crucial data about Titan, and their efforts were generously rewarded. Never before had so much data been directly obtained from a celestial body so far away on its surface. Prior to Huygens, landers had only touched down on the Moon, Mars, and Venus. What do we know now about Titan? Titan's thick atmosphere of nitrogen, hydrocarbons, and other organic compounds extends about 10 times further into space than the Earth's. Huygens determined the boundary of the troposphere at an altitude of approximately 44 kilometers. This is also where the atmosphere's minimum temperature was measured. With a temperature of negative 200 degrees Celsius, Titan's environment is significantly colder than Earth's. Inside, the temperature rises again, reaching about negative 121 degrees Celsius at an altitude of 500 kilometers. However, Titan is still much colder than Earth. This was not a big surprise for scientists, as Titan receives only a fraction of the solar radiation. The ionosphere of Titan surprised researchers with its complex structure. The main zone is located at an altitude of 1,200 kilometers. At 63 kilometers, a band of charged particles extends, dividing the Titan atmosphere into 2 chambers. Similar to Earth, Titan's atmosphere is rich in nitrogen. Huygens determined that it contains 95% nitrogen and approximately 5% methane, with the methane concentration increasing significantly in the upper layers. Methane is a gas found on Earth as a byproduct of single-celled organisms and also as a result of digestion in complex organisms like cows or humans. Methane is produced in swamps and is stored in large quantities in the permafrost soils in the northern hemisphere. Therefore, methane is a clear bioindicator. Where the gas is present, there is a high probability of organic life. However, methane is not only produced by organic structures, so it's not a definite guarantee of life. In the case of Titan, methane exists in an extraordinarily large quantity and in unusual forms. As the Cassini-Huygens mission continued, researchers found that the liquid cycles on Titan likely rely exclusively on methane and ethane. Similar to Earth, these two liquids form lakes and seas on Titan. With gentle solar radiation, the liquids evaporate, the molecules rise in the atmosphere, and then fall back to the surface as precipitation. The landscape formations that are formed on Titan bear a dramatic resemblance to those on Earth. Yet the question remained, can life thrive in such an environment? This is what life on Titan looks like. Shortly after the Huygens mission, the evidence was presented. Life on Titan is possible. The fact that Titan's landscapes consist of methane and ethane does not necessarily mean that there is no life there. In fact, the number of biomarkers found in the atmosphere indicates the possibility of life, and 2 experiments demonstrated that bacteria can thrive based on methane. Researchers at the University of Florida cultivated microbes in an experimental setup that perfectly simulated the conditions on Titan. In a short time, the DNA of these microorganisms adapted, and they began to establish a metabolism based on methane. A research team from France obtained very similar results, providing the evidence for possible life on Titan twice. But what would life on Titan look like in practical terms? If there are living organisms in the lakes or oceans, they are very likely to be single-celled. Perhaps even simple plants like algae or lichens. There may also be organisms resembling mollusks or fish in the oceans. Researchers had already ruled out the development of complex life before the Huygens mission because, according to current knowledge, sunlight is necessary for that. On Earth, certain species of fish, mollusks, or amphibians thrive entirely without sunlight and at low temperatures in caves, deep underground, or in dark ocean trenches. To be certain of what life on Titan looks like, we would need to find it, and for that, additional probes or even a rover would be necessary. However, it's probably already clear that these life forms would look much stranger than we can imagine, and they would likely have completely different respiratory and metabolic organs. People on Titan. Is that possible? The exciting question remains whether humans could live on Titan. Numerous experiments explore which celestial bodies we could visit and explore. With its Earth-like structures, Titan should, in theory, be perfectly suitable for that, right? Well, let's put it this way. A spacecraft from Earth could safely land on Titan. Encased in protective spacesuits, humans could likely stay on the moon for several hours or even days, take soil samples, conduct explorations, and search for signs of life. However, without the protection of a space capsule and constantly exposed to the surface conditions, humans would have to capitulate very quickly on Titan. The atmosphere's vapors and the cold would be challenging for the organism, as would be the lower gravity. So far, researchers find it difficult to estimate the effects of Titan's proximity to Saturn with its extreme magnetic forces. Although Titan is a beautiful and exciting place for space exploration, the living conditions there would not be suitable for us in the long run. Would you volunteer for a space flight and a first exploration on Titan? Or which other celestial body would you like to visit someday?